Gas saving is a big topic at the moment, so I want to dive into the different possibilities, especially for manual welding. Why is it such a big topic now? The reason is that, of course, also the shielding gases we use in arc welding are produced by different measures. One of them is the so-called Linde process, but here you need electricity, and electricity has become enormously expensive, and that's why now also the shielding gases are more expensive, and the, of course, ambition to save shielding gas is increasing dramatically. So what can you do? Let's describe, let's say, the welding process a little bit, and then we go into details where you can here save gas. If you start the welding process, you have a magnetic valve inside the power source that's opened at the starting point. Here the compressed gas now is expanding, and you have a huge, what we call puff of gas, so that you have a huge gas usage peak at the beginning of the process. Then, during the welding process, normally you have different weldments to carry out. Also here, between the different welds, the magnet valve is closed and opened again. This also needs some time. And if you do a weld, especially for manual welding, the welder changes the amperage, say for a certain weldment, but normally it does not change the gas. So he normally takes the highest amperage he needs for his component, let's say 350 amps, and then he uses 12 to 15 liters per minute. And many welders go more to the 15 liters per minute because they say, okay, let's go on the safe side, before I get any porosity, by putting in atmospheric gases, I put the gas a little bit higher. But now, even if they have some weldments with only 150 amps, they don't change the gas flow. They could do that for a 150 amp weld even with maybe 8 liters per minute, but nobody does it. So now here we come to the different gas saving methods. So the first thing is you can use a mechanical gas saver. These mechanical gas savers are cheap, but they only put away this initial welding puff when you open the magnet valve. So overall, you can save maybe between 10 and 20% of the gas. If you want to save more, you need more sophisticated measures. And one of them are so-called gas management systems. We can see here, this one's called EWR, Electronic Welding Regulator. So what does this do? This also cuts off the initial puff, but it has two separate possibilities to save gas. So one is that between the different weldments, this is an electronic valve, and these electronic valves can open and close extremely fast. So compared to the magnetic valve from the power source, you can really, between different valves, close the valve very fast. This also saves a little bit of gas. But the main effect is that with using these systems, you detect the welding amperage at the welding power source, and the system now regulates the gas flow proportional to your welding current. That means it automatically goes down if you weld with 350 amp, you work with 12 liters per minute. If you work with 150 amp, it goes down to 8 liters per minute without any need for the welder to do anything. And this ends up in savings of 50 to 60%. So that's a huge advantage. So you also have a payback if you use these systems for manual welding. For automated welding, robotic welding, you can do some more things. You can have an interface. You can, say, detect the gas savings live on your computer. You can send the data via internet to a cloud. So this is this EWR2 net system that is, let's say, Industry 4.0 capable. So even if you are at a remote location, you can still watch and witness your big gas savings. So there are a lot of possibilities, but to really get the highest savings, we would recommend an up-to-date gas management system. Any questions for the Weld Prof? Please contact me.